Hello, my Algebra Extended crew. We have our flip lesson today on Unit 3 functions, Day 3. So you're going to do, the first part we're going to talk about is something called discrete versus continuous graphs. And then we're going to jump right into domains and ranges, and how to identify them on a graph. So that's really going to be today. So hold on to the homework that was due today. When I come back on Monday, you will show me Day 2 homework and Day 3 homework, okay? Which is tonight's homework. After this lesson, you're going to do the Day 3 homework. All right, restricted domains and discrete versus continuous. Okay, let's talk about discrete graphs first. A discrete graph is made up of distinct non-connected points, and the domain is usually just whole numbers or integers. So like when we think of a discrete graph, we just think of a bunch of points that are not connected. Okay, that's discrete. A continuous graph is pretty much what it says. A continuous graph is when all points are connected. Continuous, keeps going. All right, so and the values include everything in between those points. So if I have a graph that has coordinate points and I connect the dots, basically, that's a continuous graph. So continuous, it says, really includes all numbers, right? Not just integers. Discrete includes just integers or whole numbers. So when we look at exercise 1 down here, and it says, just tell me whether basically this is a discrete or continuous, just think about whether the input are whole numbers or not. Okay, so for example, the cost of gas can be modeled by the function f of x equals 3.59x. So x is like how many gallons you're putting in, and think of it this way: can you put more than can you put either 1 gallon in, 2 gallons, 3 gallons in, or can you put in 1.5 gallons? 1.1 gallons. If you can put in not just whole numbers, but like decimals and fractions, that is continuous. Okay, versus B. The number of cars entering the gas station each hour can be modeled by where the cars entering, cars are not, you can't have half of a car or a third of a car, right? You can only have whole cars. That would be considered a discrete graph because it does not, remember like up here, you can't connect the dots. You're only going to talk about car 1, a whole car 1 or car 2 cars or 3 cars or 4 cars. You can't talk about any fractional cars. Okay, D. I'm sorry, C. I'm skipping ahead already. C. The charge to use an automatic photo booth can be modeled by. All right, the photo booth, when you're being charged for photos, this P represents the pictures of the photos. You're either going to get 1 photo, 2 photo, 3 photos. Again, you're not going to get part of a photo. So that would be discrete. And if we were to graph it, you would just see points on 1, 2, 3, 4. You wouldn't connect the dots. Okay, D. The function m of w equals 1/6w describes your weight on the moon as a function of your weight on Earth, w, in pounds. So if you can have fractional weight measurements, which obviously you can, you're not just going to be 1 pound, 2 pounds, 3 pounds, or 104 pounds, or 115 pounds. You're going to have numbers in between that would be continuous. And then E you can cross out. And you're all going to love this. We're going to cut out exercise 2. You don't even have to do it. We're just going to go right to the next page. I knew you would like that. All right, so we're going to talk about intervals, notation again. Remember, interval notation is something we're going to use for domain and range, but you've done this before. Remember, interval notation with the symbols, with the brackets versus the parentheses. The brackets, these are the brackets, and that means it includes a value. Parentheses means it doesn't include a value. All right, so for each of the following inequalities, write the equivalent using interval notation. So if you remember, we just did this last unit. And if it's saying that it starts at -3 and it goes to 5 and it includes everything in between, that's why that X is in the middle. And see how these are underlined? That means, again, it includes -3 and it includes 5. That's how we're going to graph it. Okay? How about this one? -4 to 8. -4 doesn't include it, right? There's no bracket, there's no equal sign underneath, so we're going to say, we're going to put a parenthesis, because a parenthesis does not include it. And 8 is included, because remember it says up here, X is less than or equal to. So that's a bracket. Okay, try 3 and 4 real quick. Take a second and try 3 and 4. Do that for me. And -6 would be parentheses, 4 would be parentheses, 12 would be bracket, 4 would be parentheses. So we should be good. Okay, now 5 is that doesn't have a start and a stop. It actually is expressing X is going to be greater than or equal to 4. So it has an infinity. So if it's X is anything greater than or equal, that means that 4 is the lowest it can be, and because there's a equals, we're going to put a bracket here. And since it's the lowest, it can go on forever up. So we have an infinity symbol, and remember, infinities are always wrapped with parentheses. So let's write that above. Always wrap -infinity and infinity with parentheses. All right. So I gave that quick little review on interval notation so that you can express domain and range using that. So when you come up here to exercise 3, it says write the domain and range in interval notation. Domain, remember, are the X's, and range are the Y's. All right, so I'm going to make this just a little bit thicker. And we're going to start with domain. Okay, now when we look at domain, we talk about X's from left to right. So what you do is you're basically looking to see where does it start from left to right. So it starts at -5. That's the lowest X value we're going to use. We're going to go, and we're going to go, and we're going to stop at 4. And we're going to include them. See how they're both included? That's how you're going to write it in interval notation. You're literally going to write in -5 to 4, and we're going to do it in interval because it includes all the points in between. And then we've got a brackets going around them because there are points there. See them? All right, so you're going to do the same thing for range. Except for this one's just a little bit different because instead of on the x-axis, you're looking on the y. So you're looking from lowest to the highest. So the lowest point that this graph goes is right here. So I'm going to come here. And that means it's at -3. And then it goes up and it goes up and it goes up. And the highest point it goes to is 3. So it goes from -3 to 3. And that is the highest point. I'm not looking at those pink points because that was not the lowest or the highest points. I'm looking from down to up. And there is a point at -3. right? And there is a point at 3, so I'm going to include those. And there's your domain and there's your range. All right, let's do it again. Domain, pink, remember. Farthest left it goes is right here, which is -1, 2, 3, 4, 5. It's -5. Okay, and then it goes, and it stops right here. This is the farthest right value it goes to, which is 2, 3, 4, 5. And it includes, okay, now this is where it's a little different. -5 is included because it's shaded. So I'm going to put a bracket here. But 5, it is an open circle, which means it does not include, it's everything up to 5. It doesn't include 5, so we're going to put a parenthesis around that. All right, do it again with range now. So go to the lowest point on this picture, on the graph that is of the function. So the lowest point I see is right here. And it goes all the way up to here. Right? All the way up. And it's open there again, right? So I'm looking at the ranges, I'm looking at the y's. I ignore left and right. I'm only looking down to up. Only down to up. So the lowest number it goes to, we said, is 0. It includes it because there's a point closed there. And it goes all the way up to 1, 2, 3, 4, 5, 6. And it's open there, doesn't include it. All right. Okay, flip that page. Let's do a couple more. We're going to do all these together because this, I want to make sure that you get them down. And then you have the rest of the period to do your homework. Okay, exercise 4. Finding domain and range on a continuous graph. All right, now, if you notice those graphs that we just did on 3, they weren't discrete, but they stopped, right? There was a start and a stop point. If you look at the difference between 4A and 4B is 4A, remember, they're both continuous because the graph is like, they're all points in between, but 4A has arrows, which means it goes forever and ever and ever and ever, right? So first thing I'm going to say is ask you, is it a function, right? So that would be if it passes the vertical line test, and it does. If I were to draw a bunch of vertical lines here, we're going to say yes, it is a function. Okay, now domain. There's 2 ways we can write. I had you do the first couple using interval notation, but there's another way as well, and we'll talk about it. Let's do the interval first, though. So as I go to the left, right, I seem to be going up, like it keeps going up and up and up and up. So doesn't that mean it's going to go to the left forever? It's not going to stop going to the left. And at this other side, it's not going to stop going to the right. So really, there's no start or stop on these as far as domain goes. It goes to the left forever, it goes to the right forever. So your integral notation is -infinity to infinity. Now, when you write that as a set, we're going to just say this is all reals. That's your set notation, okay? That's your set. As far as the range goes, remember, down to up, down to up. So the lowest point it goes down to is -3. And then does it go up forever? I know it's going left and right, but doesn't it, as it's going left and right, isn't it going up forever and ever and ever and ever? Sure is. So we're going to do -3 to infinity. We're going to include -3, remember, because there's a point at -3. So how would I write that as a range under set notation? You're just going to say y is going to be greater than or equal to -3. So your set notation is basically inequalities. That's all it is. You're looking at it, remember, you're looking at it on the y-axis. So you look at where it starts, -3 on up. Okay. Next one, function, yes or no? I'm thinking yes, right? Passes the vertical line test. The vertical line test, remember, is any vertical line I draw, it only crosses it at one spot. All right, domain, left to right. Okay, farthest left it goes is here. Farthest right it goes is here. Take a minute, write it. In fact, you know what I'm going to do? I'm going to let you write the domain, and I'm going to let you write the range, and then when I come back on Monday, we're going to look at these. So make sure you actually watched the video and did it. So you're going to do, I highlighted it for you. You're going to do B for me. Okay? You're going to do B. So on that, I'm going to do C, and then we'll stop. I'm not even going to do D with you. We'll just stop at C. We'll do one more. All right, so C, is it a function? Yes, it is. Does pass that vertical line test. Domain, going left forever. Does it go left forever? Does it go right? Is there any stopper on it? It doesn't look to me like there's a stopper, because as it goes down, I know it's going down, but it's going to the left. Continues to go to left. And as it goes down here on the right, it continues to go to the right. So because of that, we're going to do that -infinity to infinity for the domain. Which, if you remember, that would be all reals. All right, how about the range? Looking at the y's now. It's going down forever, or does it stop? It's going down forever. It doesn't stop going down. But does it go up forever? Nope. There's a stopper right there. Okay? There's a stopper right there. All right, so the range then, remember you're reading it from down to up. So -infinity to 2. And because it includes 2, we're going to wrap it with brackets. And if I have to write it as a set, we're going to say y is less than or equal to the number 2. All right, now I told you D wasn't going to worry about. Okay? You are set for that. That's all I wanted. I just wanted you to have something that was like 20 minutes or less. So we're just about 18, so I think we'll stop here. Because I want to make sure that you have some time to do your homework. Make sure that you do B here, though. I want to see that done when I come in. Okay? So I will see you Monday. Go finish B, do your homework, and enjoy your weekend. Talk to you Monday. Bye-bye.